Okay, so we're back with this again. We're still working this problem. We started out originally with this information, and what we determined was that the angle B is two possibilities, 66.6 degrees or 113.4 degrees. If it's in fact 66.6, that means it looks something more or less like this triangle, and that would make this corner 78.4. If it is in fact 113.4, then it looks something like this triangle, and in this corner, which would actually be the real C, would be 31.6. So we just have two options, so now we're going to have to figure out all the cases here. Now let's see what else. So let's figure out both cases with both of these triangles and just see what all the information says it is. Let's go with the little triangle first. Okay, we're going to use the given information to derive the rest of the information as much as possible to get our round-off error as little as possible. So I'm going to go with the given sine of 35 degrees divided by little side A, which is 7.5. This is going to equal the sine of 78.4 degrees, which is C, and I want to find little c right now because that's all I'm missing. Little algebra shows me that C is equal to 7.5 sine of 78.4 divided by sine 35. For those of you who are really never great at algebra or didn't like it, I just multiplied both sides by C, got the C up over here, and then divided both sides by this, but division by a fraction flips it over, and that's what's happened. Let me come up with a number. So that would make this 7.5 times 78.4 sine equals divided by 35 sine. C is 12.808. We'll call it 12.81. That's with, okay, so that's this C, 12.81. Okay, so for this triangle, we're essentially done. We have it all. Now I need to figure out what C will be if it's this triangle. And the good question should be, is it really going to be any different? Let's see. Eraser. Yes, I sing too. I'm multi-talented. Okay, so we have sine 35 divided by little a, which is 7.5. Now we're going to assume that this angle, this is the triangle, that the angle is 31.6. And divided by little c, which we're pretending we don't know, right? We're solving for a different triangle. So once again, cross multiplying the c and dividing by this, I get c is equal to 7.5 sine 31.6 divided by sine 35. Let's see what this is. This is 7.5 times 31.6 sine divided by 35 sine. This says it is 6.851. I'm just going to call it 6.85. Right? So what does this really mean? Well, the fact that I just extended this out like this, the picture got really bad. But if this angle, the angle C is related to 78.4, 78.4 has to be spread out at a certain kind of way, right? C has to be related to how fat the angle is. If angle C is really that skinny, it's going to have to mush this side down, which is this. So these are in fact different. And this is the exact way, or one of the many ways. You could have done order differently, but this is how we're going to analyze and break down these triangles with the law of sines. Okay, I think really that the best way to deal with these are to just do a bunch of them, and that's what I'm going to do. A good question I would like you to think about though right now is, how come we never had to worry about a case of ambiguity with the law of cosine? When we could solve one of these, how come we never had to worry about any kind of ambiguous case like we just had to deal with this? And we'll talk about it, but I'd like you to think about it. T-shirt of disgust to the rescue. And we'll clear the board. I think you can probably see how tremendously important and practical trigonometry is. Law of sines and the law of cosines. I mean, any kind of building or designing that you're doing, you can see this is just tremendously valuable. However, I mean, the truth is, a lot of you who are watching this, when you go to work, you'll be doing stuff on the computer, and you'll just be plugging in the numbers, and the machine will be spitting out what these results are. But it would be better if you knew why. Okay, so we're going to do another side angle, and we're supposed to solve for triangle ABC when B is 13. This little side B is 13. When little side C is equal to 15, and when angle B is 60 degrees. Okay, so I'm going to try and draw. So angle B is down in this corner. 60 degrees is okay, it's something like that. Side B is 13. Okay, so I'm going to tighten this up a little bit. So like this. Okay, so this is as close as I can probably get. So little side B is 13. Little side C is 15, and the angle of B is 60 degrees. Well, let's see what we can do. The first thing is, and some people are going, hey Mike, how are you picking out which things to solve for? Well, I have these relations, and so I have this sine of 60 over little side b. So sine of 60 degrees divided by 13. This is going to equal sine of a over a, or sine of c over c. Oops, I forgot. So here's a. Here's a little a. If I put sine a over little a, I have two unknowns, okay? So sine c over 15, I only have one unknown. Multiplying both sides by 15, I have 15 over 13 sine 60 degrees is equal to sine of c. We have to load up another reel, and we'll be right back.